Hey everyone, and welcome to the Foundry by Forge College. I am absolutely thrilled you're tuning in today. So, if you joined us for our previous lesson, Applied Performance Tuning, you'll remember we spent a ton of time meticulously obsessing over how to optimize our local setups for absolute maximum speed. We got things running blazingly fast on our own machines. But today, we're taking the very next logical step in your journey through Ethereum dev stacks and frameworks. We are going to take all that speed and reliability, and we're going to automate it by building CI pipelines for Hardhat.
Because, well, let's be real for a second. But it works on my machine? Ah, yes, the classic, totally dreaded developer dilemma. We have all literally been there, right? You write this brilliant smart contract, all the tests pass locally, your linting is flawless, you feel great. You push your code, your teammate pulls it down, and suddenly, nothing works. Dependencies are missing, solidity versions are completely mismatched, and it's just pure chaos. Well, today's explainer is the ultimate solution to this exact problem. We are going to eliminate the phrase, "it works on my machine," from your vocabulary forever.
Okay, so let's jump right into the overarching schematic for our automated factory line today. We're going to cover the automation blueprint, the anatomy of a pipeline, caching and amnesiac robots, guarding your secrets, quality gates and validation, and finally, next level automation. All right, station number one, the automation blueprint, drafting the factory schematic. Think about it like this. Right now, your local environment is kind of like a highly personalized artisan's workshop. You know exactly where all the tools are, but you're doing everything by hand, and honestly, the results can be a little unpredictable if someone else steps in. We want to upgrade that into a reliable, automated factory floor. So what exactly is a CI/CD pipeline? Well, in our context, it's simply an automated assembly line, and it's triggered by repository events, things like a push or a pull request. The second you push code, this assembly line spins up automatically and consistently runs your compile, test, and lint processes to enforce code quality. This is honestly so liberating. It ensures consistent quality, it completely wipes out regressions, and most importantly, it frees you up to just focus purely on feature work instead of constantly double-checking things manually. Moving on to Station 2, Anatomy of a Pipeline, standardizing our workflow. Let's really look at your local developer machine for a second. It's manual, and it has a very specific state. Maybe you installed some random global package like 3 months ago, completely forgot about it, and that package is secretly the only reason your build actually works. It's totally unpredictable. Now compare that to the CI runner, specifically GitHub Actions, which we're focusing on. The runner is automated, it's completely ephemeral, meaning it starts 100% fresh every single time, and it is unbelievably strict. It executes identically every single time, which is amazing because it immediately exposes any of those hidden dependencies you didn't even know you were relying on.
So, when a push or a pull request event actually happens, GitHub Actions spins up that pristine runner and executes 4 precise stages right in order. First, it runs npm CI for totally clean install. Second, npx hardhat compile to build your contracts. Third, npx hardhat test to validate your logic. And fourth, npm run lint to enforce formatting. Notice something? These are literally the exact same commands you already run locally. They're just being orchestrated in a perfectly sterile environment.
All right, Station 3, Caching and Amnesiac Robots, teaching the runner to remember. Now, while our strict CI runner is a fantastic, incredibly obedient worker, it does have one kind of comical flaw. It is essentially an eager but completely amnesiac robot worker. Just imagine a highly skilled factory worker who shows up to work every single day, super eager to build your project, but has absolutely zero memory of yesterday. Before they can do anything, they have to download Node.js completely from scratch. Then they have to download the entire internet into your node_modules folder from scratch every single time. It takes absolutely forever, unless, of course, we teach this amnesiac robot to use a cache. So here is how we actually give our robot a memory to build a much, much faster process. Take a look at this. For the install stage using npm CI, we can configure precise cache keys using a hash of our package.lock.json file. This magically persists your node_modules across runs. Then, for the compile stage, we cache the Hardhat's cache and artifacts directories. Why? Because if you haven't actually changed your Solidity files, Hardhat shouldn't waste time recompiling them. But, and this is a big but, notice the last row here. For lint and test, there is no cache. None. We want those quality gates evaluating the actual code completely fresh every single time to ensure nothing slips through. Which brings us to Station 4, guarding your secrets, entering the secure vault. In Web3, you know we constantly need sensitive information, right? Things like RPC URLs from Alchemy or Infura, or API keys for Etherscan to verify contracts. Students in our programs at Forge College honestly ask about this all the time. How on earth do we test on mainnet forks without completely exposing our private keys? Well, the golden rule is never, ever embed sensitive data in source control. Seriously, don't do it. Instead, you're going to use GitHub repository secrets. This acts as an encrypted, secure vault. You then reference these keys securely using environment variables or env variables, only in the specific workflow steps that actually need them. So the amnesiac robot gets the key for the task, uses it, and then poof, immediately forgets it. Okay, station 5. Quality gates and validation. Meet the strict inspector. So our pipeline might be fast and secure now, but we still need a strict inspector at the end of the line to review the logs and catch any failures. And when that inspector inevitably finds a flaw, and trust me, it will, do not panic. You just iterate. Some of the most common fixes you're going to run into include things like adding missing dev dependencies to your package manifest, the ones you accidentally installed globally on your local machine and forgot about. You might also need to pin your Node.js versions in the workflow so they perfectly match your local setup, or you might need to stub out network calls so your unit tests don't mysteriously time out because they're trying to reach an RPC endpoint that isn't mocked properly. But the crucial point here is knowing exactly what victory looks like. When you open up GitHub Actions and look at your logs, you want to see those beautiful, satisfying check marks. You want to see 2 passing and absolutely 0 failing tests. Because when you see this, you know for a fact your pipeline ran flawlessly. Your code works not just on your specific machine, but in a completely sterile, unbiased environment, and your logic is absolutely sound. Finally, station 6, next level automation, enforcing the rules. We've built the factory, which is great, but right now, it's kind of optional. To lock these rules firmly into place, here are your core takeaways for building a rock-solid CI pipeline. First, you must run the identical commands locally and in your CI, no differences. Second, you must pin your runtime versions and heavily utilize those lock file hashes we talked about to optimize with caches. And third, and honestly this is the most important part, you must go into your repository settings and configure required status checks for branch protection. This is the magic step. It converts your pipeline from a simple, helpful tool into a strictly enforced quality gate. Literally no pull request can merge until the pipeline passes. Period. But as always in Web3, the rabbit hole goes a little deeper, doesn't it? Your automation blueprint is complete for now, but I want to leave you with this provocative thought. How exactly will this newly built assembly line handle multiple Solidity compiler versions running at the exact same time? Or what about complex deployment matrices spread across completely different blockchain networks? Well, that question perfectly sets up our next lesson in the Hardhat Fundamentals module, Advanced Hardhat Configuration and Integration, where we are going to tackle those complex matrix builds head-on. But for today, our automation sequence is complete. You have taken a massive step in professionalizing your development workflow as part of your capstone project. Before you go, definitely be sure to visit forge.college to learn more about this subject and to explore our other amazing advanced Web3 related topics. Thank you so much for building with me today, and I'll see you in the next explainer.